Hello and welcome to the Learn Electronics India channel. I am Meghna, and in this video we will be learning about transistors and amplifiers. In particular, we will understand what a transistor is, the different types of transistor, its configuration, and some basic ideology of an amplifier. Let us get started with the transistor. So a transistor is also made up of a semiconductor. It is mostly used as a switch to switch between some signals, or it is used to amplify. Amplifying signal means the output would have higher amplitude. For example, in loudspeakers or in microphones, what the work does, that is done by an amplifier, and we call it as amplifying the signal. So for that, we use transistors. By either varying the current or the voltage, we can use transistor as a valve, so that controls the flow of electrons within the circuit. This important component is also used in various electronic circuits as a building block for more complex applications. Let us now understand the structure of a transistor. In general, every transistor will have three main layers, and those layers have different names based on the type. We will learn about gate, drain, and source in a while. For now, we will understand what emitter, base, and collector is. So these three terminals perform different functions. Emitter, as the name suggests, will emit something, and that is majority charge carriers. Majority charge carriers depends on the type of the transistor. So emitter is heavily doped because it needs to emit the charge carriers, and it is this terminal that increases the conductivity in the transistor. Base acts like a channel which allows the charge carriers from emitter to flow through it and then to the collector. So it controls the flow of the charge carriers, and it is lightly doped. Last one is the collector. It is moderately doped, but it is more wider than the base. And this, as the name suggests, it will collect the majority charge carriers from the base. Moving on to the types of transistors. Transistors are broadly classified based on its construction and its polarity. We have two main types, that is the BJT or the bipolar junction transistor and the FET or field effect transistor. In a bipolar junction transistor, we can control the circuit or the behavior of the circuit by controlling the current in the BJT. This is further classified into NPN transistor and PNP transistor. Whereas in a field effect transistor, the entire behavior of the circuit is controlled by controlling the voltage of the FET. Under this, we again have junction FET, that is JFET, or MOSFET, that is the metal oxide semiconductor FETs. Moving ahead to NPN transistor, the middle one, that is the P, represents base, which means the base is a P-type material, whereas emitter and the collector is of N-type material. So that is what is seen in the images here. Now, how do we decide the majority carriers? Is logically, if we see, since there are two N-type materials, it means electrons should be more, which means electrons are the majority carriers. Now, this NPN transistor will get turned on when the emitter-based junction is forward biased and the base collector junction would be reverse biased. If you can check the second image, it has the depletion regions between both these junctions, that is the NP junction and the PN junction. Now, N side is connected to negative of the voltage and P is connected to positive of the voltage, which means this emitter-base junction is forward biased. Similarly, if we come this side, P is connected to negative, but N is connected to positive of the voltage, which means this is reverse biased. So the collector base junction is reverse biased. In this state, the transistor would be turned on. And this is the symbol of the NPN transistor. The arrow mark should come outside of the base. So it is reaching towards the emitter. That means it is a NPN transistor. Coming to the PNP transistor, if we look at the symbol, here the arrow mark is coming towards the base. So it's flowing from the electron to base. This means it is a PNP transistor. Now looking at the name itself, we can tell that holes are the majority charge carriers. N-type is base and emitter and collector are P-type. Again, the concept of turning on the transistor remains same. Emitter base junction should be forward biased and collector base junction should be reverse biased, as shown in this image. Moving on to FET. FET also has three main layers, that is the source, drain, and gate. Now, all these three layers, they are fabricated on a material that is usually of semiconductor material, which is called as a substrate. So a substrate is a semiconductor material on which the FET is fabricated. Source is somewhere relatable to emitter, which means through this terminal, the majority charge carriers will enter the channel. Again, this is heavily doped because it is source, which means it needs to emit out more charge carriers. Drain is also heavily doped, and this is where the majority charge carriers will exit from this terminal, whereas gate is that terminal that controls the conductivity of the channel. So if you can see in this image, we have the source, gate, drain, and this is the channel region. So a channel is the region between the source and the drain through which the majority charge carriers flow. To this, we have the gate terminal connected, which means by controlling the voltage at the gate terminal, we can control the behavior or the conductivity of the FET. Under this, we have JFET and MOSFET as discussed. There is no much difference in the function, but it just depends on how it is designed. So in a JFET, we work on the depletion region's width through the gate terminal, which in turn controls the conductivity of the channel. Whereas in a MOSFET, here again we use the gate terminal's voltage that will in turn control the conductivity of the channel, but it does that by creating an electric field, and this electric field can either attract the charges or repel the charges. Again, under JFET, we have N-channel JFET and P-channel JFET, and MOSFETs are further classified as enhancement mode MOSFET and depletion mode MOSFET. One important concept in transistors is the transistor configuration, which means a transistor can be used in three different modes, and each of those vary based on the function that needs to be performed. Since there are three terminals, any one of the terminals should be common to the other two terminals. So we have studied that the emitter base junction and base collector junction. In that, base was a common terminal for both emitter and collector. Similarly, like that, two other configurations can be formed. So in total, those three configurations are the common base configuration, common emitter configuration, and the common collector configuration. Following are the images of the same. Now, what common base means is base terminal is used both at the input and at the output. This type of a configuration will have high current gain and low voltage gain. And based on that function it performs, it is used in impedance matching. Similarly, in common emitter, emitter terminal is common to both the input and output. Unlike the common base configuration, this has high voltage gain but moderate current gain, and it is used in amplifier circuits. Finally comes the common collector, which is also termed as the voltage follower. By now you might have guessed that the collector terminal is common to both the input and output circuits. This gives unity voltage gain, which means the voltage gain would be 1 and high current gain. And based on this function, it is used as a buffer amplifier. In these figures, in the first figure, CB mode means common base mode, which means the base terminal is coming common to the emitter and also the collector. So hence it is the common base mode. Common emitter mode is again emitter is coming common to the base and to the collector. Similarly with the collector or the CC mode. A major important application of the transistor is the amplifier circuits. So an amplifier is that device that will increase the amplitude or the power of a signal. So basically the signal will be the same, but it will be the amplified version. That is increased parameters like power, voltage and current. Simple example in our day-to-day life is the loudspeakers or the microphones. These two are different amplifiers, and this is a general symbol of how we represent an amplifier. There are different types of amplifiers based on the function they perform. So we have audio amplifiers, which means it is used to amplify or give an increased output of audio signals. Power amplifiers would increase the output of a power signal. So suppose we have a small signal of, let us say, some millivolts, and the power would get increased to some volts, then a power amplifier is used in action. Operational amplifiers are different kind of amplifiers that are mainly used in filtering, signal conditioning, filters, comparators, which we will be studying in upcoming videos. But these amplifiers have high gain and their inputs are different. Differential amplifiers, as the name says, it will amplify the difference in voltage between the input signals. And instrumentation amplifiers are specially designed amplifiers that are very precise and accurate, mainly used during low level signals. With that, we come to an end of this video where we studied about how transistors are made, the different types and the different configuration in the transistor, and how each of those configuration or that type serves a different purpose. After that, as an application, we also learned about amplifiers and the different types of amplifiers. After this, we will be studying about operational amplifiers and its application. So like we were discussing, operational amplifiers is a different kind of amplifiers and is a vast topic of study. So in the next video, we will be learning about operational amplifiers. For more information, you can visit our website. Thank you.